Hey everyone, today we are covering a topic that every developer should understand memory. Specifically, we will look at three types: RAM, ROM, and secondary memory. By the end of this video, you will know exactly how your computer stores and accesses data and why it matters for the software you build. Before we dive in, let's understand why this topic matters. Every single app you build runs on memory. Whether it's a simple script or a large scale backend system, memory is always involved. Understanding how it works directly affects how you think about performance, speed, and system behavior. And honestly, most developers skip this, but it's one of those concepts that once you get it, everything else starts to make more sense. There are three types of memory we are going to cover today. First, RAM, also called primary memory. It's fast, temporary, and holds whatever your computer is actively working on. Second, ROM or read only memory. It is tiny, read only, and only handles boot instructions. Third, secondary memory, which is your actual storage, your hard drive or SSD. It is large, permanent, and where everything lives long term. Let's go through each one in detail. RAM stands for Random Access Memory. It is also commonly called main memory or primary memory. Think of it as your computer's active workspace. Anything your computer is currently doing happens here. It is extremely fast because the CPU can access it directly without any delay. However, it is temporary. The moment you switch off your computer, everything in RAM is wiped. In terms of size, most computers today have between 8 and 64 gigabytes of RAM. So when you have Chrome, VS Code, and your app all running at the same time, all of that is loaded and running in RAM. Secondary memory is your permanent storage. This is where your files, applications, operating system, and databases actually live. Unlike RAM, data here survives even after you shut down your computer. The two most common types are HDD, hard disk drive, and SSD, solid state drive. SSDs are much faster than hard disk drive, but both are significantly slower than RAM. Size wise, secondary memory ranges from 256 gigabytes all the way to multiple terabytes. Your code files, photos, installed applications, all of that lives on secondary memory. ROM stands for read only memory. ROM is a tiny chip sitting on your motherboard. Its only job is to store the firmware, the basic instructions your computer needs to start up. Unlike RAM or secondary memory, you cannot freely write to ROM. It is fixed at the time of manufacturing. It is also very small, just a few MBs. The most common example is BIOS. That's the program that runs the moment you press the power button before your operating system even loads. Now let's talk about speed, because this is where things get really interesting. RAM operates at around 1 to 10 nanoseconds, an SSD takes about 100 microseconds, and a traditional hard disk drive takes 5 to 10 milliseconds. To put that in perspective, RAM is roughly 1000 times faster than a SSD, and compared to a hard disk, RAM is about 100,000 times faster. This massive speed difference is exactly why what lives in RAM and what lives on disk is such an important decision in system design. Let me give you a simple analogy to make this stick. Think of RAM as your office desk. It's fast, right in front of you, but limited in space. You only keep what you are actively working on right now. Secondary memory is like a filing cabinet. It holds everything, all your files, all your documents, but you have to walk over and fetch things from it, which takes more time. And ROM is like an instruction manual that's glued inside the machine. It's always there, you can read it, but you can't change it. Keep this analogy in mind, it makes the whole concept much easier to understand. So, How do these three types of memory actually work together? Here is the flow. Everything is stored on secondary memory, your hard drive or SSD. When you open an application, the operating system loads it from the disk into RAM. The CPU then works only with whatever is currently in RAM. It never directly touches the disk. This is why opening an app takes a moment. It is being copied from slow disk into fast RAM. Now, here is something important. When your RAM gets completely full, the operating system starts using a section of your disk as backup RAM. This is called swap space. And because disk is so much slower than RAM, your system slows down noticeably. This is exactly why more RAM means a faster computer. Let's bring this back to what it means for you as a developer. Databases store all their data on secondary memory. This is why database reads can be slow and why optimizing queries matter. More RAM on your machine means you can run more services simultaneously without things slowing down. If your RAM runs out and swap kicks in, your whole system will feel sluggish. When you work with cloud infrastructure like AWS EC2, one of the key decisions you make is how much RAM your server needs. A memory intensive application like a data processing job needs much more RAM than a simple web server. Understanding memory helps you make those decisions confidently. Let's put everything side by side. RAM is very fast, 8 to 64 gigabytes, not persistent, writable, used for active work, example DDR5. ROM is fast, just a few MBs, persistent, not writable, used only for booting, example your BIOS chip. Secondary memory is slow, hundreds of gigabytes to terabytes, persistent, writable, used for long-term storage, example SSD or HDD. Let's quickly recap the 5 key things from today. 1. RAM is fast but temporary. It is your computer's working memory. 2. Secondary memory is slow but permanent. It is your storage drive. 3. ROM is tiny and read-only. It only handles booting up. 4. The CPU only ever works with data that is currently loaded in RAM. 5. More RAM means better performance when running multiple applications. If you remember just these 5 points, you have a solid foundation. Thank you for watching this video. I hope this cleared up how memory works and why it matters as a developer. If you found this helpful, please give it a like and subscribe to the channel for more such videos. Drop any questions in the comments. See you in the next one.